Welcome back everybody. I'm trying a new mix on this run. I cut the cement down to 3 grams. Still using 6 grams of water. I'm using nickel hydroxide instead of nickel oxyhydroxide. Just one step away from the nickel oxyhydroxide. Also reduced the amount of carbon as well. So it's got 1 gram of nickel hydroxide, 3 grams of graphite, 4 grams of carbon, 3 grams of cement and 3 grams of water. That's for the positive side, the cathode. It comes out at 12.9 ohms. And for the negative side, using 1 gram of zinc powder, 3 grams of graphite, 4 grams of carbon, 3 grams of cement, 6 grams of water. Came out to be 8.8 ohms over that wire, and just holding the probe down here with my finger. I was playing around with it after 3 days of making it, and I broke the thing touching it. It was still under its wrapper, and I was like wobbling it like this, and it snapped that piece off. So slightly bit smaller on the surface area now on that one. That's the negative side. The positive one I didn't touch after doing that. They're a bit more robust now after 2 weeks of drying. Won't do that too much, it could snap. May not have enough cement. We were using 4 grams of cement, but I did have a video before this, but it failed to work. I made one of these for the cathode, and then put it in potassium permanganate, and that's it there. So it's gone brown. But the voltage was 1.8 after charging it for an hour, but no milliamps. Like, it wouldn't even run 10 milliamps. And I tried it with a zinc plate as a negative as well, and nothing was happening. So I think the potassium permanganate at 70 degrees may have etched into the nickel substrate we got in here. So that was a flop. And then I've been waiting 2 weeks for these to dry. So I've got a new tub of electrolyte I just made just then. So it's 6 mole of potassium hydroxide with 13 grams of zinc oxide. This is cosmetic grade zinc oxide. And so there's 13 grams of zinc oxide in there, and first run will be today. So I'll set the cell up and I'll get back. Negative side's in and it's bubbling away. Oops, my stuff's dissolving off already, as you can see, going down. So it is porous, or it's eating it, one of the two. The electrolyte's opaque-ish because 13 grams of zinc oxide has been dissolved. It won't probably take much more zinc oxide in there. Alright, so I'll stick the positive side in. Positive side's doing the same. Just connect it to the data logger now. Yeah, I've just connected it to the data logger. Haven't charged it. It's at 0.8 volts. You can see in there, you can see bits of the negative one is sort of dissolving. Might be reacting with the 1 gram of zinc in there. So I don't know how 3 grams is actually going to go. The positive one seems to be okay. So, alright, we'll give it a little run without a charge. See what happens. Alright, so that's what happens without a charge. So I'll charge it up. Probably needs to soak overnight if it survives. But anyway, we'll charge it for an hour and get back. Oops. When I did the run, I had it on the wrong end of the data logger, so it's got to go to that end. But that's the end you plug in to charge first, and then it comes out, charges the cell through there. So we won't worry about the run. We'll just charge it now. Okay, it's taking 800 milliamps through the cell, so it's looking promising. Normally They only do like 300. I'll just move that away from that other cell a little bit. So the space at the bottom is probably about 10 mil and we're about 15 mil up the top there. It's hard to see, the water's starting to change, electrolyte's starting to change colour, but the positive one sits on an angle leaning into it. So 2.5 volts, 800 milliamps. Interesting. I just turned the voltage down to 2.1 volts because it was negative side really gassing. It's still gassing like crazy. First run of the cell, 2-hour charge, holding 1.8, dropping, starting a test, 20 milliamps. Third charge on the cell, 3 hours, starting a test. That was 3 hours on charge. Okay, for the first 2 charges, 2 hours, ran for an hour and 38 minutes. Average voltage 0.92, 33 milliamps, 30 milliwatt hours. And second charge, 2.5 hours, ran for 2 hours and 1 minute. Average voltage 1.14, 40 milliamp hours and 46 milliwatt hours. And the electrolyte cleared up a bit, everything's settled down, so the cell's intact. That's left overnight in there. So see how well it takes a 3-hour charge. I finally got time to clean these from the few tests ago. These are the metal plates, nickel plated. They've been through about 100 charges. The nickel's still intact, quite good plating. So I'm going to, later after this cell, I might mix this stuff up and apply it to the whole surface of this here. So I won't use any more than that, so it's going to be thin. But I'm going to have to put either a paper towel or some sort of mesh to hold all this stuff onto there, because it probably won't bond to this, it will just fall off. So we'll have to wrap it somehow, so that's going to be the tricky part. But it will have a larger surface area and it will be thinner material. It won't be like only about that thick. This one actually is a bit thinner because it has less material. We're sticking way more material in before. So these might be interesting, scaling it up slightly. It is a pain to nickel plate because I get about 2 plates and then the nickel solution starts going all green and yucky for some reason. I'm not sure why. And we have to dump it and make a new batch. Very annoying. Six discharge of the cell, and the characteristics is not quite the same as it was the first time it was running. So for an hour's run time at 20 milliamps, it's dropped down to 0.6 volts, but as you can see the curve, it's fluctuating. So it may hold that for a while, but our milliwatt hours will be down as in energy. So last night's run, it was 4 hours and 23 on charge. I cut it off at 0.7 because it was getting too late at night, so I thought bugger it. And we only got 43 milliamp hours and 35 milliwatt hours. We peaked here on charge number 4 to 74 and 74, but I think it's on a decline. So what I think it may be is the nickel wire is getting coated maybe with nickel hydroxide and losing its contact between the carbon and itself. I say that because the voltage drops, and also the same voltage on the charge is less milliamp draw now than it was. It was up to 800 when it first went on at 2 volts, and now it's down to 100. So that's a major drop, and the resistance somewhere went up. So I might try some stainless mesh. I got some stainless mesh. I'll keep testing this, see how this goes, and I'll start forming a new one with a stainless mesh as the insert and see how that actually works, because the stainless shouldn't actually play any role in the charge, and it shouldn't really coat anything, I'm guessing. It does have nickel in the stainless, but small percentage. So this may, because it's alternating up and down here, may actually run for another 3 hours at low voltage. So now it's like functioning like a battery instead of a capacitor with the zzz and the drop off quick. Slight increase in voltage now. It's running for 2 hours. Well, just dropped because we're viewing it. A further increase in voltage, that could support the theory of the nickel mesh turning into nickel oxyhydroxide and reducing the resistance, and as it's being discharged, it's revealing more of the metal surface and contacting the mesh, the carbon perhaps, because it's very odd. We could call it the Benjamin Button cell. Still holding in there. It's been running for 4 hours and 13 minutes. The milliwatt hours is down though, and the average voltage 0.69. But milliamp hours is up, 85. Okay, back 4 hours and 43 minutes run time. 95 milliamp hours and 65 milliwatt hours, but average voltage is only 0.68 this time. And we did increase to about 0.7 and started dropping down. So it's a strange curve. Must be something to do with resistance. And I'll keep testing, see how it goes. Okay, this cell only lasted 6 runs. So we've got a good run here, and then the next day charged up for 5 hours. It sort of ran, but I had to put the cutoff voltage down to 0.1. As you can see, the negative side, the cell dissolved. I think the zinc started dissolving from the electrolyte, and that's that. So I have a piece of zinc plate in there at the moment, and still the positive one's intact, but again, when you first start the cell, I have to have the cutoff voltage at 0.1ish. Well, it doesn't go past 0.3, I could have went to, but it's after a bit of a run, it's now going back up. So I think the I do still think that the nickel wire on the positive side coats itself with nickel hydroxide and doesn't contact the rest of the carbon piece very well. That would explain why it would drop right down in voltage. Started off at 1.8 and is straight down, no load really, and then slowly working its way back up. 0.728 fluctuating, so that will probably run. We'll keep that running and see what happens. But yeah, I'm going to try some stainless wire in the next batch, see what happens then. And probably no zinc in the negative side cell. I think that's what's happening with the other cells. So you can see the nickel wire is pretty clean on the negative side. So that one's a bit disastrous, and that might be explaining why the other one stopped running after a certain amount of charges. So we'll work on those issues and see what we can get. So I'll be back when this runs out. Sort of the voltage is going up still. Well, actually it's fluctuating. Okay, updating the load to 50 milliamps. It should be able to handle that because the zinc plate as the anode. Okay, we dropped in voltage pretty well. 0.28. See if it's increasing or it decreases. Okay, we'll leave it running. It seems to be going up. Okay, after that run, I've decided to put the positive cell on a piece of stainless steel as a collector, just with 2 rubber bands, bypassing the center mesh, the nickel mesh. Going from this same zinc cell as the negative. I think you can see the outline just there and over there. Okay, so the voltage, it's connected to its original connection. It's at 0.5 volts, connecting it to the stainless pad. So we're at 0.7. We've probably got a bit of contact to the cell now. So this is our graph for the last 4 hours of running at 50 milliamps, 178 milliamp hours, 74 milliwatt hours. Average voltage is about 4, but I think the resistance on the nickel wire has gone up. So we will start a test without charging. Nah, we're doing better before with it connected. So I'll just connect it to the other plate. Well, I mean, I connect it back to the nickel wire. So the nickel wire can actually do 50 milliamps at 0.2 volts, and the stainless collector can only do 22 milliamps. So looks like the internal resistance is less, but it's a bit strange how the stainless one is less. I'm connecting it to the nickel wire mesh. I'll let it run for a while, see what happens. Connect it to the stainless mesh. Okay, looks like the stainless pad is only doing 14 milliamps, so I'm quitting for now and I'll charge it up tomorrow and see what happens. Okay, back. The cell's been on charge for 3 hours with the positive now attached to the stainless steel collector. They're still running a zinc plate for the negative cell. So it was, as you can see, there's no drop in the charge current for some reason with the stainless steel plate. So 20 milliamp test starting now. And that just dropped right off. So performance, zilch. So I'll just connect the positive lead now to the original alligator clip, or the nickel wire, what comes out. It's 0.8 volts on that one, but I think it's dead cell. Okay, at least that holds a little bit better. So something wrong with the cell. It definitely looks like, I don't know, some connection issue maybe with the voltage going up a little bit. So I'm going to reproduce the same cells, but I'm going to use this piece of 316 mesh fly screen wire. The magnet doesn't stick to it. It might be a bit fine, I don't know if the cement will actually hold, but I'll cut it a bit smaller so there'll be cement around the outside, should sort of just encase it. So I'll make one of those. It takes about 2 weeks to dry, so I'll try various things with this cell and see what I can do. but it's definitely dropped in performance for some reason with the less cement. So what was different with this one is we only used 3 grams of cement on both of them. So I'll make a negative one without the zinc powder. I'll just add an extra gram of carbon, or maybe graphite. Not sure. But see how the voltage is still increasing slightly. There was a spike then. I'll just move the cell around. Nothing happening there. The alligator clips are pretty clean. I don't know, maybe not. I just wobbled that one on the end. Okay, I'll get back. Okay, so that's it for that cell. And I made up the new cells. I only put 5 grams of the water and a few drops to make it a little bit more stickier. That way I could compress the 2 cookies. So I've also put a weight on top of them now, so I'm going to hold it under compression while it dries. Not sure if that's a good idea. So the anode will have no zinc powder this time. I added an extra gram of carbon, and this one's identical. Now with the nickel wire in the cell, I smashed these ones off. Now see that space in the middle? Right, that's nickel that sort of must have dissolved because it doesn't sort of break apart. And over there, see those little breaks? So charging the nickel wire inside the cement definitely has an effect on the nickel wire. That one's intact though, and it looks a bit cleaner. So that one might have been a negative cell. And this one, which is totally missing, it just dissolved completely, had longer charges, I think, and then I decided to put it in some potassium permanganate. So potassium permanganate seems to dissolve nickel under a charge more rapidly, because once I put it into the potassium permanganate and on a stir bar and heated it for 70 degrees for 2 hours, this cell no longer functioned at all. So I think it's lost its connection between the mesh and everything. So maybe the stainless mesh, wherever it is in it, maybe hopefully a better option. But other than that, it's looking like the graphite is the best option so far. It's definitely ran longer with the graphite than it has with the nickel. So hope you enjoy this video. I'll see you in 2 weeks, no 3 weeks. It'll take 2 weeks for those to dry. Another week to do some testing, and then maybe post a video if it's not looking so good. Alright, hope you enjoyed this. Thanks for watching. Okay, I have the 2 new cells under a brake drum, a brick and a 5mm plate. I'm going to hold them under compression until they dry, just to see if that does a bit better job.